Hello guys, today we're going to take a look at a Britain's power farm model from the 1980s, and it's a County 1884. So this probably would have been the precursor to the RC car. It's basically a tractor model with a motor and a gearbox in it, so it's able to drive, and it also has a little PTO shaft on the back here. So we have a lever here that engages and disengages the PTO, and the button that gives us the power or puts the drive to the motor, switches on the motor, is just here. So we'll push that over. So that's how simple it is. Just push that over, and if we disengage that little lever, now we should see this little PTO spin here, but the drive wheels won't engage. So see it's spinning there. If you take a look there, you can see the Britain's England 1987 patent pendant. So that was back when this was first developed. So what's powering this model is a simple AA battery. You just lift off the bonnet here. There's your AA battery, and the way the switch works is also very simple. You can see the little tab in here, and if we push the button, you see the tab moves forward. So that moves forward and it just pushes on the top here, top of the battery, and it pushes the bottom of the battery into this other tab. So that's how you get your power, just pushing on those tabs. Maybe we can see it. So you've seen the battery move there. So that's how simple that little mechanism was. So that's quite a good idea. So we've a single AA battery driving this, so I wonder, is it going to have any power at all? And remember, this is a motor from the mid to late 80s, and I would imagine it would have been even a cheap motor for back then. So I'm not really expecting it to have a huge amount of power, but let's bring it up to the model farm and see what it can do. So we have our county here on the diorama. We have sandpaper road here, pretty much the ideal surface. Should be very little resistance for the model. So let's set it going and see how it drives. So that was no problem to it. It cruised along there on the perfect surface without any difficulty. But how's it going to react if we put it on something slightly more difficult? Okay, so we have the county on this little field display here. There's not much to really stop it here. It's just paper on top of a flat sheet of plyboard, so there shouldn't really be anything to stop it, but let's turn it on and see how it goes. So there's a fair bit of resistance there. It's not a huge obstacle really, that cardboard, but it's enough to stop the little tractor. Okay, so the field didn't work out, and my plan had been to tow the baler in the field. So since that didn't work there, let's give it a go on the ideal surface and see if it can even pull it on the tarmac. So it was clearly under a little bit more pressure than it had been the first time we went along this sandpaper road, but it still was able to pull the baler there without huge amount of difficulty, I suppose. But that's only with our 1.5 volt battery. We'll have to see how it'll respond when we up the voltage to our 3.7 volt Lipo, or will the motor even survive that for very long? I imagine it should. I wouldn't expect there'll be any difficulty, but we'd probably end up changing the motor anyway, so it's not a huge problem if we do damage it. Well, as expected, we didn't get a huge amount of power from our single AA battery, but what if we hooked up one of our 3.7 volt Lipo batteries to the tractor. We're going to get a higher voltage, which should give us more power. Still, I would be surprised if we actually gain all that much power from the motor. The best thing we could do to make this a reasonably good RC conversion would be to somehow get an N20 motor into it. But for the time being, we'll try and start with the motor that's in it and see how we get on from there. Okay, well, just for a quick test, I have one connector in here, one of the DuPont connectors. We're hooked up to a Lipo battery here, a 3.7 volt one, so that's kind of 4.2 volts fully charged. We have a positive here, and I'm just going to touch it to the positive contact in here, so we'll see our PTO at the back start to spin there. So that's very obviously spinning faster than it had been the first time. Now, whether we've actually added any power or not is going to be a little bit trickier to demonstrate. So I'll have to make a bit of a better connection here, and I guess put the battery in a trailer and see can it pull the trailer. Well, I think I've got the distinct smell of a motor that's not long for this world, but that's what we do on this channel. We're trying to figure out what is going to work, and if it doesn't work, how are we going to make it work? Well, there's a couple of downsides to using the motor that's already in this tractor. Probably the biggest downside is the noise. It is very, very noisy relative to, say, your N20 motors. It's very, very noisy. And as well as that, again, relative to your N20 motors, you're using a huge amount of current. When it's driving forward, it can be using between 40 or 400 and 600 milliamps. That's a massive amount of current, considering the John Deere 8360R. I think both of those motors, if they were flat out, would only be using 500, and it is massively powerful. So to be using over half an amp and still have very little power doesn't make much sense really. But are we going to be able to fit in an N20 motor into this model? That's the question. Will we even be able to get it apart? Okay, so we're back up in the attic now. We'll give the county a go at pulling the baler again. It didn't work the first time for us, but now we have our 3.7 volt battery. Let's see what's going to happen. So that seemed to be no problem at all to it. So I guess what we'll do is bring it on the tarmac and we'll try and pull something difficult like the low loader. Okay, well, pulling the low loader round a corner is probably one of the most challenging things for any of the models to do. Most of them struggle with this, but we'll give it a go with the county and just see what happens. I'd say that was actually reasonably successful, and the reason I'm saying that is because the lifting point on this tractor is a lot lower than on the newer ones, so I'd say the trailer's probably lifting it slightly off the ground. Maybe if we put some weight on the front, it might be a better test. Okay, well, it's definitely not putting weight on the tractor now. I can see that the hitch on the trailer, or the hitch on the tractor, is being pushed down, so let's just see if it'll pull this. No, looks like we've overloaded it now. We've hit its limit. Well, it seems to be able to pull it in a straight line, but it doesn't really seem to have the power to pull it around the corners. But that's not really what we'd want it to be pulling anyway. This is what I'd really wanted to be able to pull, just a very simple dump trailer. I think it would just look perfect behind it. So if you liked that video, make sure and hit the thumbs up, and if you want to see how it turns out, if we actually get into the gearbox of this model, make sure and tune in to the next episode of this. But that's all I have for today, so thanks very much for watching.